Hello everyone, this is Group 34, CST Year 3 Civil Engineering. We are going to show you how we can perform a shear strength test by using direct shear test machine in a simple way. So what you have to do is just first you need to know why you need to perform a shear strength test. This is the objective of doing a shear strength test. It's just to determine the shear strength parameters known as cohesion and friction angles. Those are the materials you are going to be using. Here is shear box. This shear box is the stuff to hold the sample. So during the test, so this shear box is having two parts. It has two parts, the moving one and the halves one. So we will be using also a sampler. This sampler is the stuff we are going to use by considering the sample. We'll be needing also a dial gauge for reading the vertical displacement. We'll be needing a dial gauge for reading the horizontal displacement. We'll be also needing a dial gauge for reading the shear loading. So we will also need a llama. This llama will help us to organize a sample. During decoding, it will be better if we are having a stopwatch, so that we'll be conducting our test by taking a sample or a decode after 30 seconds. So there are some procedures you have to follow so that you can perform your test as well. So you have to find a certain site and you dig a sample undisturbed one. You bring the sample to the soil laboratory. You make sure that the sample you brought is having different grains. It is well so that it will be able to have a shear strength. So during when you get the sample to the test, you make sure that you organize it. Let's now start the test. So I suppose that every material is around so that we will not be disturbed by going away finding the materials. So here, remember, we are going to find two parameters, cohesion and friction angle. So we first need to know the dimension of the sampler. So we need to determine the height of the sampler and determine the width of the sampler. This is the way of determining the height of the sampler by using a vernier clamper. It's a vernier clamper. It is having a graduations, so that it is in millimeters. So if you define it is in centimeter. So this is the way of measuring the width. So after getting those dimensions, we will be able to determine the area, and after determining the area, we'll be able to determine the volume, and after getting the volume, we'll be able to find the density of the soil, because we'll be knowing the mass of the soil. This is the way of preparing the sample. So you take a sample, you insert the sampler, and you make sure you're having a good smooth surface of the sample inside the sampler. So after getting it, you take it to the electrical balance. Make sure that the electrical balance is connected to the or is plugged, and make sure it's initialized to 0. You have first to determine the weight of empty sampler. So you put in the balance and you record. So you see that it is having 133.7. This is the weight of the sampler. So we need now to determine the weight of sample plus sampler, and after getting this weight, you need to subtract them and make a difference so that you will be able to still having the weight of soil, and then take the weight of the soil divided by the obtained volume, so directly we are getting the density of the considered soil. So next, what you will do, also make sure that the soil or the sample is having a flat surface. This flat surface, it's just to help us to reduce or avoid the presence of gap. By removing the presence of gap, also provide a good shape in order that we are having a few voids. So this is a shear box. A shear box is having two parts, as I said before. The upper part is the moving part, and is normally called a halves one. So we need to fix them with pins. There's two pins, so that it is well fixed. So you need to press a metal plate down And you need also to press another pret instead of perforated one. So you need to press a grid pret. This grid pret must be, those grid lines you are seeing must be perpendicular to the direction of shear strength. You need to take a specimen, press it as well, so that when you are pushing the sample, you will be fitting the bottom of the shear box. You need to put the top, make sure it is well pressed, push the sample down slowly. Yes, make sure it is going down and is fitting to the bottom. Yeah, and after, yeah, you have to push it, and after, if it is well fitting down, you remove the sampler with the top cover, and after removing, then take back the cover, use it to push down the sampler and make sure it is fitting the bottom press as I said. And also take the grid pret and make sure those grid line must be perpendicular to the direction of the shear. Now get another pret, metal pret, instead of using a grid pret. So next step, you need to press a grid pad so that you curve it. This grid pad, you are seeing it is having a hole up. So this hole up, it's where you fix the load, the tool to the tool that is having a load, and press it down. Make sure you fix the cover as well with using the screwdriver. Now you and after preparing the sample, you take it to the direct shear device, and I assume that you have just initialized all the stuff before. I mean those gauges and the proving link, so that you can conduct your tests as quick as you can. So after installing all the stuff, make sure that you install the box as well, and then start recording. Remember, we are recording at after 30 seconds. So this is the way you have to record it direct as soon as possible for those 3 gauges, for the proving link one. And this is how after recording, this is how the sample will be looking after doing the shear strength test. This is, we're having a normal stress and a shear stress, the shear strength directed horizontally. This is the way, because the grid was somehow perpendicular, that's why you're having those line above the used sample. And you know the stress, when you are stressing the soil will be disturbed until it reaches the fail. So after doing the test, we suppose that we are having collected the data and we do the required calculations. So what you now want, it's just to draw a certain graph. So we're having a graph of normal shear stress against normal stress, and this graph will be able, or by using it, you'll be able to determine those 2 parameters you'll be looking for. I mean, there is cohesion parameter C is after calculation we have found that it is equal to 0.13 kilogram per centimeter square, and we are able also to determine the angle, friction angle, which is equal to 25 degrees Celsius.